This video is about hyperbolas, found in section 9.4, and this is part 1. All right, first of all, we want to compare ellipses and hyperbolas. In an ellipse, we saw that the basic definition involved that there were two given points called the foci, and there was a given distance. And any point on the ellipse, if you measure its distance to each foci, the sum of those different distances was always going to be the given distance, or the sum of the distances to the foci is always a certain constant. With hyperbola, it's a similar idea, but it'll be the difference between the distances is always constant. So in a hyperbola, and there are two parts of it called branches, there are two foci again, and if you take any point on the hyperbola and you measure its distance to each foci, the difference of those distances is always equal to a given constant. And I put it here in absolute value to show that you are just talking about the positive. So whichever one is larger, subtract that minus the smaller one. All right, now there's two ways our basic hyperbolas are going to go. They can go where the transverse axis is horizontal. All right, the vertices are here and here, and they are on the transverse axis, and so are the foci. All right, so that's a vertex, that's a vertex, that's a foci, that's a foci, that's a focus. Or the transverse axis can be vertical. Okay, and here's a vertex, here's a vertex, and here's where the foci would be. And they're on the vertical transverse axis. All right, now how can you tell which way it's going to be? All right, it's all in the equation. So here's a sample equation. Y squared divided by 16 minus x squared divided by 9 is equal to 1. Notice it looks a lot like the standard form of an ellipse, but this one's a hyperbola because we have subtraction here. So this is the form, and we're going to use the a squareds and the b squareds again. Whichever one is the positive coefficient. The coefficient on y squared would be 1/16. That's positive. So whichever one is the positive one, you write that first, and that one is going to be over the a squared value. And if the y variable is first, then the transverse axis will be the y-axis. Okay. The other way, the other axis, we call that the conjugate axis. And then in this one, the vertices are going to be 0, 4, and 0, -4. Those numbers come from the a values. Right. Here's what the graph would look like. So here's a vertex at 0, 4, and here's one at 0, -4. All right, and so here was the transverse axis. That's like the main one. And then the one going the other way, that's called the conjugate one. Okay, and so the a value gives you your vertices. So in this one, a squared 16, so a is 4. The foci are also on the transverse axis. So in this problem, they are 0, 5, and 0, -5. We'll talk about how to figure those out in just a little bit. All right, and then these will have asymptotes. And in this case, the asymptotes have these equations. All right. You're always going to want to find the asymptotes when you're graphing, because when you know the vertex, then you can basically draw in a basic graph of your hyperbola. Okay, so this one, the branches are going up and down. The transverse axis is vertical, and that's because the y squared comes first. That's the positive coefficient one. Now, if we look at one with the x squared, starting, and this one has the positive coefficient, 1/25 it would be, then the transverse axis is going to be the x-axis. And here's a graph of what this one looks like. So here's your transverse axis, okay? And the a value will always go with that first variable, the positive one. So in this case, a squared is 25, so a is 5. So that's why we have vertices at 5, 0 and negative 5, 0. There's your vertices. Okay. And then the foci, looks like I wrote these the wrong way. It's going to be on the x-axis. So square root of 41, comma 0, and negative square root of 41, comma 0. All right, and the square root of 41 is approximately 6.4. So you can see here's going to be one focus, and here's the other one. All right, but they're on the transverse axis, and then it has asymptotes. Okay. All right, if you look at the asymptotes of this particular one, all right, you can see we are using the center to be the origin, and the slope of the asymptote, if you go up 4 and then right 5, this has a slope of 4/5. And those are the numbers coming from basically your A and your B. So that the B is going to help you draw the asymptote. Okay, so here's the general game plan, how to graph hyperbolas. First thing you're going to want to do is plot the vertices, and those come from using whatever A is. And then you're going to want to sketch the asymptotes, and the asymptotes are going to be diagonals of a rectangle that you draw using the values of A and B. And once you have the asymptotes, then you can draw in the branches of the actual hyperbola from the vertices, and you just draw it near the asymptote. Okay, so let's try one specific one. Okay, let's say we got x squared over 4 minus y squared over 9 is equal to 1. Okay, so see, this one's starting with the x squared. That's got the positive coefficient. So the x-axis is going to be the transverse axis. All right. So just mentally in your head, if here's your x-axis, you can picture that it's going to have this kind of a look to it. The branches are going to open to the right and to the left. Okay, so this will be the form, and like I said, whichever one comes first, the positive one, that will go with a squared, and then the other one will go with b squared. So it's not like the ellipse where a is always larger than b. Not at all. A always goes with the term with the positive coefficient. Okay, so in this problem, we've got a squared equals 4, so a is 2, and b squared equals 9, so b is 3. So a will tell you the vertices, okay, and they're on the transverse axis. All right, so in this case, you can just look, it's with x, so they're on the x-axis. So we just, on the x-axis, since a is 2, we'll go 2 to the right, and then we'll go 2 to the left. All right, so each one of those is a vertex. Okay, and then you use your b value. Okay, you're going to use a and b to draw a rectangle. Draw a rectangle. Okay, so you're going 2 to the right, which we already did, and 2 to the left, that we already did, but then the b value is 3. So you're going to go up 3 and down 3 and draw that rectangle. Okay, so from the center, then you're going to go up 3. I'm just going to put a little x because that's not an actual point. That's just helping you draw the rectangle. And you want to do this whole rectangle very lightly. So this would be the rectangle. I'll draw it a little darker so you can see it, but in general I usually draw it pretty lightly. All right, and then if you draw in its diagonals, those are the asymptotes. So from here to here, this is a diagonal, so you just continue it on. So you can see it's got a slope of 3 over 2. 3 over 2. They're not always nice whole numbers, so you just find the rectangle and draw its diagonals. Okay, so that's one asymptote, and then here's the other one. And it has a slope of negative 3 over 2. All right. Okay, so don't need the rectangle. And even the asymptotes are not like technically points of the graph. So those are dashed lines. A little messy there. Not the best eraser. All right, but in any case, these are asymptotes. All right, they show you the actual graph is approximately near those. Definitely not my best asymptote. Okay, so the hyperbola has the vertices as actual points. So you're just going to approximately draw the branches like this. So they kind of look like parabolas, but technically they're not. These are part of hyperbola, so they have slightly different curvature. And there you go. That's the graph of the hyperbola. All right, now, if you need to find the foci, or if they tell you the foci and you're supposed to draw something else, the basic rule for the foci of of a hyperbola is c squared equals a squared plus b squared. So this is like the Pythagorean theorem. Okay, this is for the hyperbola. Remember, for the ellipse, it had a minus. Okay, so on the last one that we just did, if we wanted to find the foci, we had a was 2 and b was 3, or a squared was 4 and b squared was 9. So c squared is going to be 4 plus 9. C squared equals 13. So c is the square root of 13. Which is approximately 3.6. Okay, so just remember, the foci are always on the transverse axis. Okay, so they're like inside each branch. So 1, 2, 3, 3.6 be about here. That would be a foci. 1, 2, 3, 3.6 in a negative direction. That would be another foci. Okay, so the only 2 points I have on the graph for this one are the vertices.